In today's video, we're going to look at section 8-5, classes of functions. So some of the special functions that we've already dealt with would just be these basic line functions. We first have the constant function where it's y equals a number, so it can be any number, and that would create a horizontal line at that number. The next one is a direct variation function where it's a line that goes through the origin. So y equals a times x. We previously just learned it was y equals k times x, where it can vary depending on what book we're looking at. Then the identity function is the same thing that goes through the origin, but it's just y equals x. Okay, that it would be also called the parent function of a normal line. All right, so then we have some more. We have the greatest integer function, where it is a step function. So it kind of looks like steps, and it's got that double bracket around the x, so it's y equals that double bracket x. Then we have the absolute value function, where it creates that v, y equals absolute value of x. And then we have the quadratic function, where it's y equals a x squared plus bx plus c, where a is not equal to 0. So we create a parabola. All right, so then we have a few others. We have the square root function. If an equation includes the independent variable inside the radical sign, the function is a square root function. So it's half a parabola turned sideways. That's the basic. Then we have the rational function, where it's a polynomial divided by a polynomial. So p of x divided by q of x. Okay, and we might have one or more asymptotes and or holes. We've talked about that previously. And then we have the inverse variation functions. So it's y equals a over some x. Okay, so where p of x is a constant and q of x is equal to x. Okay, so we have a lot. So we want to be able to identify these. So identify the type of function represented by each graph. So the first one we have here, it's a sideways half a parabola. So that tells us it is a square root function. And there we go. Okay. Next one, we have a line with a hole in it. So this one is a little bit tricky. It is a line, but since it has a hole, we have to make the assumption that it is actually a rational function. Okay. So please, you've got to keep that in mind. It would be considered a rational equation. It appears to be a line, but with that hole, it creates a rational function because there's something being brought out. So a rational function. All right, just because of that hole in it. Oh, can't spell function today. The next one, we have what looks like a step function, and we know this to be the greatest integer function. All right, and the last one. Here we have just an upside down parabola, and we know that as a quadratic. There we go. All right, so Emily launched a toy rocket from ground level. The height above the ground level h in feet after t seconds is given by the formula h of t is equal to negative 16t squared plus 80t. Which graph depicts the height of the rocket during its flight? So negative 16t squared, well, t squared or x squared, that represents a parabola. And which one represents a parabola? And that's a quadratic. So we know B is our graph because that creates a quadratic parabola. Identify the type of function represented by each equation, then graph the equation. So the first one, y equals absolute value of x minus 1. So that tells us it's an absolute value. Well, that's easy. So it's absolute value and then we just need a graph. So we can just plug in numbers And I'm going to start with plugging in 0. If I plug in 0, I get -1. If I plug in 1, I get 0. If I plug in -1, I would still end up with 0. Okay, and there we have our V absolute value. Okay, next one, y equals -2/3 x. Well, that's a pretty easy one. That is that's just a line function. It's a linear function. So we can use our y equals mx plus b abilities. Intercept is 0, and then do our slope, down 2/3. And because it's a line, there's no holes, so we just connect our 2 points, and there we go. Very simple.